Hey everyone, welcome back to the shop for another episode of Tool Tuesday. So in today's episode, we're going to be focusing on changing out a couple of my Facemill tool holders. Recently, I installed two new Ingersoll Facemills, and we're using both of those for our drill index, our drill index production. One of them, the illuminator, roughs out the bottom of it. And then the other one is the die post finish, which makes one pass across the top here. Leaves a really beautiful finish there. And those are both mounted on just standard Facemill holders from Technics. Nothing wrong with them whatsoever. But our VM is equipped with through spindle coolant. And I haven't utilized that yet for any of our production. So I'm slowly trying to step into that and change out some of these tools a little by little so that we can utilize our through spindle coolant. And the first thing we're going to do is the Facemills there. So we got two of these from Parlec that have the holes machined in there that allows you to use through spindle coolant. So the coolant will be spraying directly out onto the inserts. So we're going to start with that. I want to get these swapped out. No big deal. We'll get these swapped out. I just wanted to share this with you, and we'll get them swapped out, touched off on the tool setter. And then I have two drill indexes that are unfinished for Op 2, and I'll be able to use at least the eliminator on those two and see how the through spindle coolant is going to work, if we have any advantages there, any benefits. I'm hoping that it works better, not only for the cooling of the tool and the workpiece, but maybe it won't spray as bad. I don't really know until we get in there and see. But regardless, that's what we're going to be working on. I am going to be following up very soon with another interesting video because we have a new speed increaser tool from Ingersoll as well that we're going to be putting in the machine here to use for our engraving. Now, I haven't even gotten out of the box yet. I haven't figured it out. That's the next step for me, is to get that out and get it on the machine and start doing some testing and proving. But my goal was to hopefully, whenever we get to the speed increaser, that's going to decrease the cycle time of our parts that we're making here. And the other change that we're making is that whenever we do the Op 1 and Op 2 of our indexes, I'm not doing any of the engraving. I don't have any of the fractional letters engraved on the racetrack, nor do we have any of the data information engraved on the bottom, because I wanted to go ahead and make the swap to do that engraving after the anodizing is finished. I think that's going to give it a nicer look. I think people are going to like that more. It's going to give it a little bit of contrast. So that's what we're shooting for. And with the addition of the speed increaser, I'm hoping that that's going to relate to a decreased cycle time. But I don't know until we get started, just to see how that's going to improve our quality there, or our cycle time anyway. But we'll get to that later. Today we're going to focus on our new Facemill holders. So we'll go ahead and take tool 2 and tool 3 out, get them swapped out. I'll show you what our Parlec tool holders look like, and then we'll get them set up and then run a test on our Op 2 and see how the changes work. All right? We'll start with tool 3. It's already loaded, so we're going to remove this and call up tool number 4. This one is our illuminator that we use for roughing. We'll go ahead and pull tool number 4 out now. This is our 2.5 inch die post finish. Got the finishing inserts for aluminum. That's what's creating our finish cut on the top of our drill index there. All right, so here's a look at our standard Facemill holders from Technics. We'll be removing the Facemills from these guys. And then we have our new Facemill holders here, our through coolant Facemill holders from Parlec. So these are made in USA. Should be some really high quality tools here. And then we also have a couple of the retention knobs we'll be putting in there too. These are the proper ones for coolant, same as that you see right here. And I wanted to give everyone a reminder there as well. So Parlec is owned by Technics, and a while back Technics created a promo code for all of our A-Bomb 79 followers and watchers out there. If you go to the Technics website where you can purchase their tools. You can use the promo code BOOTH20 and they're going to give you 20% off anything that's over on the website, whether it be retention knobs, tool holders of all different types. If you want a shrink station, a vortex cooler, any of the stuff on the website, you can get 20% off. All right, so you can visit our website, abomb79.com. We'll have a link there in the tool crib. You can click on it. It'll take you right to the Technics website if you want to. So let's go ahead and pull one of these guys out and take a look at it. I haven't seen one yet. That's a nice way to hold that. Keeps it centered up and from moving around in the case there. So you can see on the pilot, on the face of the pilot here, you have 6 holes that are machined in there that allows your through spindle coolant. And remember, you have to have the correct retention knob there as well. These are the ones that we're running for our Milltronics, and Technics makes, they make these in many different configurations. So there's our retention knob with the hole through there. So we're going to get all this cleaned off first, and then we'll go ahead and get them installed. Whenever I clean off our new tools, I like using the chlor-free degreaser here. It works really well, dries very fast, and just blast the oil off. And just take a good rag and just wipe it clean. Just getting all that shipping oil off of everything. We'll go ahead and get our retention knobs tightened up on there. All right, we'll get our face mills off the old holders here. Just seeing if those bolts were the same, they look like it. Now, what I'm looking for here is I always put the SP350 rust inhibitor on my tools when I put them together like that, and you can still see some residual oil lubricants in there just to keep everything lubed, any kind of rusting from forming in there over a long periods of time. Looks good. So these are going to be used again with some other face mills. So we'll get these put into the drawer. Yep, still got that rust inhibitor in there. Looks good. All right. So let's go ahead and get them installed. Make sure those faces are nice and clean. I'm going to go ahead and clean the tools off as well. So this is what I like using for any rust inhibitor purposes around here. Works really well. Just give it a little dab like that. I'm going to check the torque on those bolts, but otherwise these guys are ready to put into the machine there. I got my torque wrench set to 50 foot-pounds. These are 3/8 bolts here. All right, these guys should be ready to install and touch them off. We're going to go back in with our tool number 4, and I'm going to go ahead and touch these off so that I don't, it's easier for me to go ahead and install a tool and touch it on the tool setter and move on to the next tool. Otherwise, I can't remember, and I don't have enough confidence knowing that I touched off a tool. So I try to play it safe by just touching them as soon as I install them in the machine. So that's our tool 4. We're going to go to Run Program and Tool Set. Have to have the door shut for everything. All right, tool number to set, offset, and that is tool 4. Tool number 4, active, that's the one we want. We're going to hit enter. And we only want length because I'm just going to plug in the diameter that we want it to be, 2.5 inch nominal size. So 0 for length, enter. Tool diameter, 2.5 inches, enter. All right, now we have to hand wheel it, Z. I'm gonna hand wheel it down. We'll get it close, and I have to offset it in Y to get it touched off. So I'll restart this and put the camera in there so you guys can see that. Okay, that looks good there. Remember that runs in reverse when it touches that stylus. So now we're ready to install tool number 3. Okay, that looks good. All right, our 2 tools are touched off and ready to go. Now that we got our tools in there, I'm going to give the CTS a try. That's the coolant-through spindle. Let's see what it does. It was dirty. Certainly is putting out some coolant, not only through the Facemill, but it looks like it's coming through the taper as well. Let me check the pump over here, make sure everything's looking good. Oh, you know what? Our coolant's low. I'm going to turn that off. I need to top off our tank. I didn't realize it was so low. So I need to top off the coolant tank. I didn't realize it had dropped down that far. So we're going to go ahead and put some fresh coolant in there. We're going to come over here to our mixing station. This is the coolant that we run in our CNC mills. It's from Master Fluid Solutions. It's the Trim Microsol 685 XT. That's what they recommended we run. We started with the 685, and they said the XT has some additives there to help prevent the foaming more so than the 685. So anyway, that's the coolant that we're running right there. The water comes in from the tap water supply, the city water supply. We have a couple of backflow preventers per code on here. And then this water comes through the mixing station. It siphons the oil up, mixes it depending on the ratio that we have this set out here. And then it goes up to our Reelcraft hose reel that we're gonna pull directly over to the mill, or whatever machine that we wanna put coolant in. This is a 50-foot hose reel, and it will reach every machine in the shop, including the Trim Microsol, which is the furthest point that the hose will reach. Super nice system. Easily just lay it right there, anywhere. And I'm going to come back over here and turn this ball valve on. Now, as I said, you can adjust how much oil, and I've got it set at the number 2 on this right here. You have 0 through 10. Whenever you're just kind of topping off a coolant tank, you really don't need a whole lot of extra coolant oil in there. So therefore, we take it somewhere between the 2 and 3, and then we will actually measure it using a refractometer to make sure that it's near the correct ratio that we want. So we're going to go ahead and open that valve. That's going to let the tap water come through here. And then I have an additional ball valve on the end of the hose here. And that's just straight tap water pressure that's coming through. It's going to put it in there just like that. And then we'll just fill it up till it's at the top of the sight glass there. So the way that this coolant system works, this is your CTS pump right here. You know, through spindle coolant, coolant through spindle, coolant through tool. I'm still trying to figure out how to actually say it, but on the machine it's CTS. But anyway, that's your standard coolant pump is back there on that tank. This is the additional high pressure pump system that's bolted to that tank, which fills this sump up with coolant. This is a feeder pump which pulls coolant from this tank up to this tank. This is your high pressure pump motor right here. So this is going to put out your high pressure coolant needed for the through spindle coolant there. So just thought I would point that out. And I'm just going to watch this and just fill it up to the top of the tank there. Going to take the tool out and CTS. Well, that's spraying hard through there. That's okay. I just wanted to kind of even out the coolant. I can see that it's drawing it down on that sight glass right there. You can really see how much pressure comes through that spindle. Perfect for deep hole drilling. So CTS, this button right here. I think we're topped off well. So we can just come to our little ball valve here on the end and just shut it off right there. I think that's good enough. I'll go ahead and get the refractometer ready and we'll go ahead and test it and see where our bricks level's at. We got our refractometer here. And we're just going to get a little sample of the coolant with a little dropper. Put a few drops on there, hit go. We're looking for about 8. 6.2, not where it should be. It needs to be a little heavier than that. But we're pretty well topped off. So what I'm gonna do from here is just keep taking some measurements, because sometimes it needs to cycle a little bit and kind of get mixed up better. And if I need to, I'll just pump a little extra coolant in there, try to get it to the 8.0 that we're looking for. I'm gonna go ahead and just do it one more time, because sometimes it does change a little bit. It's even less that time. So that's saying it's less than it should be. So I'm going to continue working on that, but we're going to continue working on getting our tools installed for now that I got enough coolant in the sump here. And then when I'm done, go ahead and close off that ball valve right there. I love my coolant system. This is so convenient to be able to just pull the hose to the machine, turn it on, and fill the tank up. So I think I found out what the issue is. Whenever we first tested our through spindle coolant there, I saw coolant coming up, what looked like out of the taper. I didn't look at this heavily earlier and noticed that there was actually ports machined in the top of the flange of the tool holder here. There's also 2 on the bottom. So Parlec had set screws in the bottom to plug these 2 holes off here, and there wasn't any on the top. So I believe the coolant was spraying out of these 2 holes on the top of the holder there. Pretty sure that's what the problem is. So I went ahead and took the 2 set screws out of the bottom, put them in the top, snugged them up. Now we're going to see if that fixes the issue, because as long as your taper is correct, which I don't know how it could be off, but it could be, but that should be right. You shouldn't have coolant coming through the tool here. That should be a fit all the way across that taper. No coolant should be able to get through that. Let's try it again and see. All right. Turn it on and see what happens. I think that was it. So yeah, those 2 set screw holes on the bottom of the flange, it's definitely coming through that now. And it doesn't look like it's coming out of the top. I thought that's what the issue was that we had like a bad taper, but we don't. So I'm gonna have to pull the other tool and do the same thing with that. So I'll just go ahead and do that next. So that's looking better. I'm gonna go ahead, while we got that on, let's turn it on. I accidentally hit cycle stop. That's not what I wanted. All right, we're gonna go CTS, clockwise on, cycle start. There we go. That's only running at 800. We can go up to 1400 right there. I'm looking forward to watching it do some cutting over here and see how it reacts. Stop, CTS off, and we'll go ahead and go to MDI. We want tool 4, M6, run, cycle start. All right, I'll jog it down so it's a little bit easier to see that. Let's try the CTS here now. Yeah, same thing. So this side's a little bit clear. You can see it spraying up towards the spindle, and that's what I saw earlier that I knew wasn't right. So we'll just go ahead and do the same thing. We'll fix it. It'll drop coolant on you if you not careful. So yeah, set screws in the bottom holes, but not in the top. So we'll just swap those out. There's our set screw. Go ahead and put it on that side there. I'm just going to run it down until it gets tight like that. I can tell they have thread locker on these. Okay, let's see if that fixes this one. It should. Put it back in. And then shutting the doors just so Abby doesn't get sprayed with coolant here.
Thank you, babe.
All right, I'm going to turn it on. Let's see what it does there. Beautiful. All right. That was an easy fix. I'm glad that I figured that out. I'd never even noticed those set screws in the tool holder before, so that's something that I'm going to have to start being more familiar with as I get into more of these types of tool holders that accept through spindle coolant. All right, good deal. Well, that kind of fixes that issue there. So next step is I need to edit my program for Op2 and change these tools so that that face tool is going to be for Op1, so we're not going to see that right now. I'm going to go ahead and jump over to Op2, which is going to use our 2-inch illuminator, but I need to edit the program in here so that it's using the CTS coolant through spindle. See, I don't want to say coolant through spindle. I want to say through spindle coolant, but I don't know. CTS. So let me make a mod to my program, and then we'll jump over there on Op2 and see what it's going to look like with our, what is it? Coolant through spindle. I don't know. I'm totally screwing that whole thing up. Just through spindle coolant. That's what I'm used to saying. So we'll be back when I get the program edited. All right, we made an edit to the program here in the text editor. I already run a simulation here. Everything's looking good, but I'll show you what I did. We're going to go to program. I'm going to hit last because it was the last one that I did. So I've got a program where I did this before where it only machines the hat and the pocket out because I was testing that tool there. So we're just reusing that same exact program. And right here on line N7, that was our M8 code for the coolant right there. And CTS is M63. So all I did was just modify that M8 code to be an M63, which is for CTS. And I did the test at the end of the program here, all the way at the bottom. M9 shuts the coolant off. And I know that's for flood coolant, but it's working also for the CTS. So I left that alone. And so it's working good now. I did a little air cut just to make sure it was going to work, and it's there. So I'm going to go ahead and adjust my coordinate down, and we're going to watch it rough out the bottom of our drill indexes using our CTS tool holders for our face mills. So back out of this, run program, and we're ready to start. I know it's really difficult to get good video outside the machine, and I apologize, but hopefully it'll clear up a little bit on the window here. So far I'm liking it though. It doesn't matter what window you go to, every window is covered in coolant, so it's just hard to see it outside the mill. Well, there it is, finished up. That took about 3 minutes to do that. I'm gonna go ahead and open the door up there. But I gotta say, I love the performance of the through spindle coolant there, the CTS, and our new Facemills. And I think that's gonna work great. It's gonna benefit us nicely, properly lubricating the inserts and helping to blow all the chips out of the way as we're doing the machining. So I'm a happy customer today. Well, I think that's going to wrap up this project and this video, and I'm happy with the results. Our Parlec Coolant Blast Facemill holders are working good. I'm glad that I figured out the little set screw issue. And by the way, I went ahead and measured one of these. They are 4mm set screws. I don't have any on hand, so I'm going to get a little pack of them ordered so that I can go ahead on these types of tools here. I'm sure I'm going to end up getting some more of these things. I can go ahead and plug both sides of it because honestly, I don't see the benefit of spraying coolant out with what I'm doing right there. And I don't know if it's going to make a difference plugging it either, but I am going to get some set screws and we'll go ahead and plug these holes so that it's just forcing the coolant through the ports onto the carbide inserts of the tool there. So anyway, we had a successful run roughing out the bottom there. I really like the performance of the tool with the CTS. I think it's working better than it was. I just really like the look of it washing the coolants away and being sure that everything's getting lubricated as it should during the cycle of the program there. So that's going to wrap this one up. So I do have a follow-up. I'd like to come back with another episode. I've got that speeder unit that we're going to be getting unboxed. I've got to get it hooked in the machine, do some testing, and see how it's going to work. But I'd like to bring you guys back when I have that figured out and show you that addition too for the engraving. So we're just trying to make small improvements here or there. I will say that adding these Facemills to my drill index program has greatly reduced the cycle time, which is resulting in an overall cost drop for us. So we've already dropped the price of the drill indexes. You can see those over there on the ABOM79 website. And my goal is to continue trying to bring the price down so that it's more affordable for everyone that might be interested in buying one. So that's the goal here. Invested in higher quality tools, better tools, and reducing the overall cycle time for our parts that we're making, so that we can give you guys the best price out there possible. All right, so that's it. I hope you guys enjoyed today's project, and we'll see you on the next video.